Okay, so usually this is something I do in the classroom. I'm gonna tell you a little story about Pat and Sue, okay? So, they met their first week at Marshall, and he is just gaga over her, okay? And she knows it. That's just basically, and I think we kind of all know those relationships are a little bit out of balance, okay? And so when we talk about this, and let's say they were making plans for Saturday, and he was just like, "Well, I was thinking maybe, would you like to play I don't know, Fortnite?" And she's like, "No, Saturday nights is the night I do my TikTok thing, so we need to like, do that. And you said you were gonna help me. So guess what they're probably gonna do this weekend? TikTok. Yep. All right, because she is the one that right now is calling the shots. Now, I'm not saying this will last forever, but I'm just saying that right now she decides because she's like, nope, no TikTok. We are totally doing, I'm sorry, no Fortnite. We are totally doing my little TikTok thing. Okay. So we have two variables in this situation. I forgot what I said their name was. Um, Pat and Sue. Is that what I said? Pat, that's him. He is the dependent. Okay. If I want to know what they're doing this weekend, I'm not going to go ask him, okay? Because he's just going to do whatever she wants. And she, I think I called her Sue. Sorry, I forget my memory. So Pat and Sue. Sue is the independent one, right? She is calling the shots. You think she's affected by the fact that he wants to play Fortnite? I don't think so. Okay. So let's kind of keep this in mind as we go into actual problems here. And you can draw your own conclusion who Pat and Sue is. Let's see. Okay, example 2A, independent versus dependent. In warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and the dependent variables for this function. So let's start off with identifying the variables. Those are the two things that are in relation with one another, okay? In our last problem, it was what? Pat and Sue, right? So in this particular problem, it is electricity and the daily average temperature, right? So probably like the hotter it gets, the more electricity you use to run the AC. And then on a nice, beautiful day like this, where it's a little cooler, we don't use very much electricity at all, right? So I'm just going to write down temperature and electricity. So the independent is the one that we have to know first, right? The other one follows. So which one is it that will follow the other, right? Another way of thinking about it is which one is unaffected by the other, okay? So in this case, the one that comes first is the temperature outside. This is our independent, okay? So it's not going to get cooler outside just because I decide to use electricity. It's not going to get hot all of a sudden because I decided to crank up my AC, right? That's not really how it works. It's the temperature is unaffected by the amount of electricity that I use. So it is the independent one. Here, electricity is totally dependent. The amount of of electricity that I use is, well, it depends on the temperature outside, right? Okay, so I hope that pretty clear. Example 2B. Again, we have another scenario. The number of calories you burn increases as the number of minutes that you walk increases. Okay? Identify the independent and dependent variables for this function. So what are the two things that are in a relation here? What are the two things that we're comparing here? Okay, so one, we have the number of calories, and the other, we have the number of minutes. Okay, so the number of minutes that we walk, maybe minutes that we walk, and the number of calories. I'm going to go ahead and write those down. number of calories and minutes I walk. Okay. Which one? Oh, that I burned. Number of calories burned. I'll just say it like that, right? So which one do I need to know first? Okay. I think you know that the number of minutes that I walk is what is going to happen first. Okay. It is unaffected, I guess, by the number of calories I burn. So what I mean by that is um I'm going to walk, and then that does determine the number of calories burned. This is the dependent, okay? The number of calories burned depends on how many minutes I walk. Dependent. You got to think. I mean, I wish it wasn't that way. I wish I could just sit on my sofa and I'm still going to burn the same number of calories, but it actually doesn't, okay? It's however much I walk, more I walk, more calories I burn. Example 3. The graph represents the temperature inside on a winter day. Describe what is happening in the graph. So, I mean, essentially, as here we have two variables. We have temperature and time. Because this is on the x-axis, it is what? Dependent or independent? Let me go ahead and dry mix out. Dry mix. Okay, x-axis is the one that goes horizontal, right? I had a student tell me one time, Miss, I know because I go like this, boop, boop, and it makes a Y. I'm like, okay, whatever works, right? So this is X, it's your horizontal axis. This is independent, right? So the time is independent. And our temperature is on the Y-axis, and that is dependent. So essentially, this is saying that as time goes by, time stops for no one, right? That the temperature kind of came up, went down, up, down, up, down, up, down, up, down, and then finally down, okay? So I kind of thought, let me kind of write a little story. This is kind of what I imagined happened, okay? So this is what I wrote. When we got home, the house was freezing because it's December and my house is old. I used to live in this really old house. And I like it warm, so I turned the heater on, right? And the house became warmer over time. So that's initially this part right here. Let me go ahead and okay, that's initially this part right here. So here, cold, you walk in the house, right? Up goes the heat, yes? And then it became warmer. So my husband doesn't like spending money and he doesn't like it warm in the house. So he turned off the heater. And so what happened? It got a little bit cooler, right? And then a little bit later, I was like, ooh, it's cold. I turned that heater back on. And then this happened a few more times. Turned it off. I turned it on. He turned it off. I turned it on. He turned it off. I turned it on. And then when he turned it off, finally, it broke. And so we spent the night in a cold house. Yes. Not a true story, but it fits the graph. Okay. If you have any questions on anything today, please let me know at sync time or come see me in tutoring. Good luck on your practice problems, okay? Have a great day. Thank you for spending time with me.